We will continue with our first speaker now after the break, Ms. Angelica Rota. She graduated from Bari University of Technology, and she is currently also doing there an industrial PhD with the support also of AGC. And she will give a nice presentation, I am sure, about the reuse of post-consumer flat glass. So, Angelica, the floor is yours.
Thanks. So thanks for following my presentation this afternoon. And I'm very glad to be here and present to you the results of my research about the reuse potentiality of post-consumer glass, which I developed in collaboration with a few other colleagues from the architectural department of AGC Glass Europe. So during this presentation, I will start by showing you the business as usual scenario, which involves the architectural flat glass. Then I will show you how it's possible to move towards a circular life cycle by reusing the post-consumer glass panels to remanufacture a new IGU. Then I will present to you the steps that we followed during the quality investigation of the post-consumer glass. In the end, I will show you the results of the mechanical investigation, and I will try to draft some conclusion based on these results. So currently, the linear life cycle of architectural glass is mainly linear, with the glass that ends up in landfill at the end of its life cycle. And during this open loop, the glass waste that is produced could be divided into two categories. We have the pre-consumer glass waste and post-consumer glass waste. The pre-consumer glass waste is produced before the glass reaches the market. Instead, the post-consumer glass waste are produced during or after the use, so during the installation, the service life, and the demolition phase. So far, only the internal pre-consumer glass is actually recycled back in the float line as cullet. Instead, the post-consumer glass is almost never recycled. But let's talk about some numbers now, which can give you the idea about the relevance of these problems. So every year in Europe, around 1.5 million tons of post-consumer glass are produced during demolition and refurbishment projects of the buildings. And when we compare this number to the number of production of one float plant, it came out that the glass waste are equivalent to 6 times the early float plant production. So when we look at these numbers, we should really try to answer the question, to this question. So what we can do with all this amount of glass and how we can try to collect and recover them. And in the rush to provide solutions for these problems, we should not forget that every circular action has different environmental benefits associated. And the waste hierarchy triangle here represented shows you which are the different environmental benefits associated to the circular action that could be undertaken in the end of the material life cycle. So this triangle would suggest to prioritize, for example, the reuse, and the waste prevention over recycling, recover, and disposal. So although when we speak about glass and we speak about recovered glass, recycling is the most widespread solution, maybe we should try to do more than this. So applying these circular actions to the management of the construction and demolition waste could be done every different, so throughout every different stage of the building life cycle. And starting from the procurement of raw materials, whenever we decide to reuse a component or a material, we should have a certification of these secondary materials in order to have a sort of warranty about its quality and to promote its use among the stakeholders. Then, during the design phase, we should really try to integrate the design for disassembly approach in order to allow that all the materials and all the components of the system could be easily separated in the end-of-life stage. Then, during the service life, having the metadata of a material or of a component is really useful during the collection and sorting operation that could happen at the end-of-life stage. And still, in the end, the selective deconstruction is preferred over the demolition, because only in this way we could try to collect and separate and recover the materials of the buildings. But let's come back to glass. So how could we apply all these circular actions to the management of the glass waste? And the question is, how could we move from the situation shown in this picture, where the insulated glazing is simply crushed and sent back to a landfill at the end of the building life cycle? In our research, we focus on the possibility to reuse the post-consumer panels to remanufacture a new IGU. And besides, a quality protocol was studied in order to provide a certification of these secondary materials, so to move from this situation to that situation. Here, I'm going to show you how the linear life cycle that I've shown you before would become circular by reusing the post-consumer panel to remanufacture a new IGU. So let's consider to implement the selective deconstruction operation at the building service life. This would allow to collect the glazing components, which can after be sent to a disassembling facility. And once the glass panes are separated, they could be sent to a window maker in order to remanufacture an insulated glass unit, or they could be recycled and shipped back to a float line, or in the end, they could be sent to landfill. So here I'm going to show you instead the flow chart, which better explain the process and the decision process and the necessary operation involved in the glass panel reuse. So broadly speaking, after the collection, the harvesting of the double glazing and the disassembling of the double glazing, the glass pane should undergo in a quality protocol. And I will give you later during the presentation more details about this quality protocol. And this quality protocol would say to us if the glass pane is good enough to be reused, and in this case it can be stocked, or it could be also recycled. And whenever the glass type is not good for recycling, there is also space for downcycling applications, or as least option, landfill. I mentioned before the disassembling of the IGU. And actually, this operation is not an operation that could be easily done manually, and especially in a fast way. So here, a disassembling machine, an industrial disassembling machine, is required, is needed. And in this context, and with this purpose, AGC and EGLA have developed this disassembling machine that is shown in the picture, which is able to separate the glass panels from the other components of the IGU, so the sealants and the spacer. And if you want to know more about this machine, you could follow the presentation which will be given by Marco Zaccaria tomorrow at the same stage and also at the same time, actually. So we can meet here tomorrow to learn more about this assembling machine. I mentioned before the quality protocol. And the quality protocol is the important, the most crucial step in the glass panel reuse process. The first, and is involved a lot of parameters in this quality protocol. The first parameter to consider is the glass type, because depending on the glass type, the other quality parameters could change. In our research, we focused only on the annealed clear glass. And so for this type of glass, the other parameter that we considered are the visual quality and the mechanical performance. The visual quality took into account all the defects that is accumulated on the glass surface. Instead, the mechanical performances took into account the strength of the glass. So here you can see the steps that was followed during the quality assessment of the post-consumer panel. So first we went with the harvesting phase of the double glazing from residential buildings. Then we manually disassembled the IGU in the laboratory. Then a surface scanner located in a production line was used to spot the defects distribution on the glass panel surface. And in the end, the post-consumer glass was tested with a coaxial double ring test in order to assess its mechanical performance. So during the harvesting phase, again, we collected 43 IGU from residential buildings during replacement and renovation projects. And you can see in the graph that how these IGUs are distributed by their year of production. And as you can see, most of the collected double glazing were from the 1980. So in general, a service life of more than 41 years. Here instead, I'm showing you which step we followed for the manually disassembling of the insulated glass unit. So first, we opened the IGU by cutting with the blade the sealants in the space between the spacer and the glass pane. Then we manually separated the components of the IGU. So we took out the glass pane. And since the depollution of the glass surface from the sealants remaining is quite difficult to achieve, we decided to go with an edge trimming of about 3 centimeters from the glass edge. And in the end, we cleaned the glass both with a washing machine and manually. So once we collected the insulated glass, the scanner gave us information about the distribution of defects on the glass surface, and this allows us to classify the glass into 3 different quality categories. The quality level 1 here is actually the same specs identified in the product standards, which is the EN 572, so the product standards of the glass. And after these specs were doubled and tripled in order to create the other 2 categories, so the quality level 2 and quality level 3. So in the graph, you can see how the glass that we scanned is distributed among the different quality levels. And most of the inspected glass falls in the out of quality level 3 categories, which we can call it also an unqualified categories, because actually this category includes all the glass that was highly damaged, and for this reason they weren't even scanned, such as the corroded glass. Besides, the output of the scanner helped us also to guess what was the former position of the panels in the IGU, and with the idea that the most damaged surface belongs to the external panel. In many cases, the scanner confirmed the hypothesis, the assumption that we made during the disassembling of the IGU, based on the clues that we collected during the disassembling, such as the presence of fungi on the surface of the outer panel of the IGU. So once we visually classified the glass, we performed mechanical investigations. So we tested with the coaxial double ring test around 30 series of glass with the 10 millimeter sample dimensions. And the failure stress data that we collected was after statistically analyzed with the 2-parameter Weibull distribution. So here you can see both in the graph and in the plot that is in the table and in the graph, that is reported the comparison of the characteristic bending strength results for the quality level 1 glass and the new glass, because we tested also a series of new glass. And this comparison actually helps to highlight the main finding of our study, which is that the surface quality classification has an effect on the mechanical performance of the glass, and actually the new and post-consumer glass tested with the same ring size shows similar mechanical performance, because the 53 megapascal of the post-consumer glass is highly comparable to the 58 megapascal of the new glass. So indeed, the surface quality classification shows an effect on the mechanical performance. And this can be understood also when we see at the results of the series tested with different quality levels. So you can see that the quality level 3 give a characteristic bending strength of 37 megapascal, which is which give us a decrease when we compare it to the 53 megapascal of the quality level 1 glass. During the mechanical investigation, we also investigated another parameter. I told you before about this, so the tested phase. So if there was an influence of the former position of the panel in the mechanical strength of the glass. And actually, the results of the mechanical investigation highlighted an unexpected results because the internal faces of the panel, so which here is called the faces P2 and P3, show a lower strength compared to the external faces of the glass panel, which is the faces P1 and P4. But maybe this investigation would need to be repeated and improved by keeping as consistent parameters both the tested phase and the quality levels, which here is not the case. So as general conclusion, I would say that also to answer to the question that I put in the slides before, is it possible to reuse the post-consumer glass? But a quality protocol is needed in this field because only by undergoing a quality protocol we should assess if the glass quality is good enough and we could reuse the glass, or if it's better to send it for recycling or downcycling applications. In the end, I want to also raise another question. So what we can do as an engineer and as a designer to transform the glass waste into resource. So to move from the mindset of waste to the mindset of having a resource and no longer a waste in our hand. So in my opinion, the key solutions are find alternative solution to landfill, but really valuable alternative solution to landfill, and this applies not only for glass waste but also for the all construction and demolition waste. Then also we would really try to maximize the reuse of the full facade, including all its components and materials. And in the end, we should really try to integrate the design for disassembly approach and principles when we decide a building facade. So thanks for the attention, and I'm open to any question or suggestion that could came from the audience.